This is part one of manufacturing a new controller for my Genmitsu 4040 Pro Max. Replacing the standard controller that comes with it, which is only grbl 1.1 capable, with something that can do either grbl HAL or I'm going to use FluidNC, at least to start with. And I'm going to use a PiBot controller, which, contrary to the name, it does not have anything to do with the Raspberry Pi. It actually uses a ESP32 WROOM type of controller. Pretty cool. I like the FluidNC setup. So you can, I'll put a link, but you can see my setup for my CNC. And I've already have new cables added. I use aircraft connectors, and I'm going to leave that intact so that I can use the old controller if I were to need to, but also so that it's a little more generic and that this controller can be used for a little bit of everything. So the case is a bit large, but the controller card isn't that big, but it does have all terminal connectors, takes up a little bit of space. The wires come out from the sides, not the top. So you need space on the sides, and it uses external motor drivers. You can see I have 5 of them there. I have X, 2 for my Y. I have it left and right, and then Z and my A axis for a rotary axis, 4th axis some people call it. So what I'm using is I think the case is a little bit larger than it needs to be, but it leaves itself for some expansion. But it was originally made to sit like that, and it is steel, not aluminum, for what that's worth. So what I did was I took this clamshell from the top and I cut it so that I can remove the clamshell. And I'm able to turn it up on the side. Now, I blocked off the vents here because I do not want any air getting in from the bottom, like dust or I do mostly all aluminum milling. Do not want that getting up in there. I'm going to have airflow going in a different direction. But I have mounting holes made for this 24 volt, 14.6 amp Meanwell power supply, one of the better brands. So it fits in right here. Going to bolt in, and it has all the access here. So everything on this has terminal, screw tight terminal connectors, which is okay. It's good, definitely better than little pin connectors or anything like that. But with that in mind, you don't want to be able to, or you don't want to use just plain strip of wire inside those. That won't work well. Some people like to solder the wire, tin it, but that really doesn't work too well. It's not very flexible. You end up with possibly only a few points connecting, and solder can tarnish. So I bought a whole bunch of wire furls of different types and a crimper for them so that I can make nice square, you want square type furls that'll go into here. So I'm starting on, as you can see here, this is a loop. So instead of just doing a daisy chain of the power going from the power supply and daisy chain from one to the next to the next, I decided to do a whole loop to help the current have a better direction, instead of having to go from one to the other, and maybe one's drawing more and taking from the other. So the loop seemed to be a better choice. This is an approximate mock-up of the PiBot controller board. I just needed something to kind of give me a rough idea what it's going to look like. So it has, these are all going to be terminal connectors, and I'll put a link and some pictures in the rest of the video for what it really looks like. But these are terminal connectors that are the outputs to the external controllers. Now, it does have an option that you can buy these little plug-in controllers that are low current, but I wanted something expandable, higher current, and I'm probably going to go with NEMA 23 motors in the very near future. These are all going to be the terminal connectors for the other inputs and outputs, your interlock switches, laser control, all that kind of good stuff. It comes with this neat little plug for a little bitty OLED display you can put on there. I bought it. It was only like $5. Should be here in another couple of weeks, the whole thing. I don't see any reason to leave it on here. I might put a larger one on the front panel for the heck of it, but we'll see. The thing that gets me is that the SD card slot is right here in the front. I don't know if I'll be using that, but I definitely want to have access to it. So I'm going to put it on some extensions, put it right up to the very front of the panel, and cut a slot that hopefully will be good enough to get the SD card in and out. Now, I'll see when it gets here, but that should work for that. Now, I have plenty of other room on the inside for, I'm even thinking about putting possibly some high voltage relays for controlling stuff like the vacuum. Right now, I'm running a trim router, and I'm using an IoT, Internet of Things, power distribution unit type of remote control for it, and I'm controlling that from the controller using the laser control for it, and that turns it on and off, and you can plug different things into it. 110 volt. I have my vacuum in it, the trim router, and I use a solenoid to cut the air supply that I use for cooling and chip extraction. Also connected in that is 110 volts. So I might actually integrate some of that into here. So the front panel right now, to go in the front, is pretty sparse. I have a power switch. I've also have a emergency stop switch. I don't have it right here with me, but big aluminum emergency stop switch. And I'm going to wire that up a little bit differently than most of these hobby type controllers do. They only have a signal that goes to the grbl controller to tell it to stop processing grbl. In my experience, on my machine, every time I've had to use it, it does not work. There's a problem, and stopping the code, if it even tried, did not happen, so I had to hit the power switch. And I have a power distribution unit going to everything. I just cut everything off. So what I'm going to do is twofold. Each one of the motor controllers has an enable signal. Normally you would just jumper that to be enabled all the time. I'm going to run it through the emergency disconnect or emergency stop switch to disable these. I thought about just cutting the power completely, but since it has a cool little enable and it's a low voltage, low current signal, I'm going to use that. And then for the output that's going to my power distribution unit, the IoT that operates my vac and all that stuff, I'm also going to run it through there through a little relay that'll get the power to it to turn it off as well. I'm going to try to make this as versatile for anybody that may want to use it and copy this and use it for something else. And then it'll also send the emergency stop signal to the controller itself, so it can stop running the code, prompt the appropriate error, and put that up. So that's kind of what it's looking like so far. The back panel is going to be pretty busy. So right now I have the top area is going to be for the aircraft connector type switches. I'll show those in just a minute. And then I need one of those for a little bit of everything, each axis, and I'm going to keep the left and right y-axis independent. It has its own motor controller, and that's so hopefully I can implement being able to align those programmatically. Right now I have to use, I have a couple of measuring devices. I made basically a jig, a spacer that I put on each side before every run to make sure that both X and Y are true. And it's amazing how far off they can be sometimes. So it would be kind of cool to have that in there. And I also want to change from the mechanical limit switches that I have right now, the little relay or micro switches rather, to proximity sensors, which the FluidNC and the PiBot controller totally support. They aren't too expensive, $5 or $6 a piece. It'll take making some brackets and adjusting everything, but there's enough I/O ports on the PiBot controller that I can have a limit switch both on the positive and negative of every axis. Right now, the way the Genmitsu is set up, it shares a limit switch on each end. So technically the controller doesn't know which end triggered the switch. It tries to guess by which way the motor was going at the time. But if you get into a problem, you have to power it on and it's already been tripped, it has no idea where it is. So that would be cool, and that would also help with, on the y-axis, since it has independent motors, to be able to do alignment with that programmatically. Of course, I'll have a regular power cord receptacle, power switch for the front, illuminated. The e-stop will be on the front, and it's a pretty large aluminum e-stop. Once you hit it, you have to twist it to re-enable it, the typical type thing. We'll have inputs and connectors for all the limit switches. Right now I'm using 4-pin aircraft connectors for pretty much everything. I believe I'll keep that like it is, and that will allow me to have the plus and minus axis limit switch connect together on one connector. So pretty much the way I'm going to have it right now. And this area up here is where all those aircraft connectors are going. And those look like this right here. So that's what I'm using right now. I already have wired up and cabled, so that'll fit right in. They're good connectors. These are not waterproof like true aircraft connectors of this style would normally be, but I did not need that, did not want that. So this will work just perfect. Have plenty of good premium cable, silicone, nice and flexible that I'm using. The internal wiring is all silicone. 18 gauge most everywhere, 16 elsewhere. The cables going to the stepper motors are all 16. but I'm looping the power to everything instead of just piggybacking it, like I said. So the power supply itself has 3 connectors for both VCC and ground. So I don't think I'll need a terminal block for the power distribution. I'm just going to use those. You'll also notice that I not only crimped, but I soldered the connectors too. As almost 40 years worth of electrical engineering and a lot of practical experience and a lot of mechanical engineering, you can never make anything too sturdy. I don't care what kind of crimp you have, how good it is, they can come loose. So it doesn't take but just a second to heat that up and solder it, and you don't have to worry about it again. So that's where it is so far. I still have to work out the airflow. So the power supply has its own fan, and this is the intake. Output goes here. So I'm pretty sure I'm going to have an output vent right here. And then I do not want anything on the top. So the grates openings that were there on the original case, I'm going to cover in some way. I'm not sure how. But I don't want, all the debris and dust from the shop to be able to land there. Even if you got a filter on it, that's the place where everything lands. Why have it horizontal when it can be vertical? So I'll probably put it over on this side someplace. The way my CNC sits, this will be away from the CNC, so that kind of helps, but this will be the input. It'll bring air in, and since there'll be a case here, it'll force it down through these fins, which these really shouldn't ever get hot enough to need air cooling, but inside a case, it could accumulate a lot of heat. So it will need some, and of course, this is going to need some air. So I don't want the heat from this rising up and heating up these either. So I figure exit right here with a filter on it, input here, and a filter on the outside of that. So that's kind of where I'm at with it right now. I think it's going to turn out pretty good. I am also going to change the color. This is an okay blue, but I don't like it. So I'm going to change it. The problem is that these are plastic. So you can buy plastic paint that works pretty good. But kind of want to go with black, but I'm not sure. I'll try and decide on what colors to go with, but probably not going to leave it this blue. I just really don't like it. Not a big deal, but right now while I'm building it, I'm going to have to disassemble again. Going to have to drill more holes for the mounting of the controller board, etc. And then I'll lay all the holes and everything out for the connector and do that in Fusion and CAD that out and then cut it on the CNC to make nice mounting holes and everything. So I believe after that would be a good time to paint it since I'll have everything apart. So I'll see where I go with that. Thank you.